Okay, so 1.6 notes is talking about inverse and reciprocal trig functions. We talked about the regular three trig functions, sine, cosine, and tangent last class, how to calculate their values. So now we're going to look at what it means to take an inverse trig function, which we already kind of know, and also talking about a reciprocal trig function. So first of all, an inverse trig function, you've seen this before, right? The little -1, we've done it in this class. Now we did it with a calculator. What am I looking for if I'm looking for an inverse trig function? What is the output? What's the answer?
The angle.
An angle, correct. Okay, so if I take inverse sine of some value, then I get out an angle measure. All right, so we're doing this in radians. Radians and degrees, remember, they're just two different systems. They're measuring the same thing. It's like temperature. I can give you temperature in degrees Fahrenheit or degrees Celsius, right? It's measuring the same temperature, it's just a different system. So think of radians and degrees much the same way. So we're dealing with radian measures is what we're going to be sticking with. So if I want the inverse sine, I used x as my variable. It doesn't have to be. It could be a y, it could be a, it could be whatever. It's just inverse sine of something is going to spit out angle measure. So the answer is going to look like a radian, so pi over 3 or pi over 4 or something like that. Now there's new notation. Have you ever seen this notation before, this arc notation? No? Okay, that actually means the same exact thing. It's a different notation for inverse sine, all right? It's actually what we use a lot in pre-calculus and calculus, more so than the -1 in simple, all right, to denote inverse. So what that means is it's the angle measure. So when you take the inverse sine, cosine, or tangent of something, you get an angle measure at which the sine of that angle equals that x value, okay? All right, note, this is very important. The inverse sine does not equal the reciprocal of sine, okay? That's something that, because we're going to be talking about reciprocal trig values, that's something entirely different. Oh dear, sorry. Okay. All right, so that's something entirely different. And so if I take, for instance, 1 over x, sorry, I didn't mean to do that, x to the -1, you would say 1 over x, right? So the reciprocal of x is its inverse, okay? But with sine, cosine, and tangent, that is not the case. The inverse is not the same as the reciprocal with sine, cosine, and tangent, okay? It's the inverse function. So if I take sine of an angle equals something, if I take that inverse sine, I get the angle measure, okay? It's not division, right? It's not a reciprocal. A reciprocal is division, which is not the inverse of sine, cosine, tangent. Okay, so that is not the case when we're dealing with trig functions, okay? All right, so let's look at some examples. So this is where you really need to be familiar with your trig values. So instead of me asking for sine of an angle and you give me the x coordinate or the y coordinate, sine would be y coordinate, this time I'm saying the sine of theta equals √2 over 2, and you need to tell me which theta that occurs. Now, I'm telling you in example 1 that we're looking just at thetas from 0 to 2 pi, not including 2 pi, okay, so all the way up until 2 pi. All right, so for the first one, sine theta equals √2 over 2. That's saying, okay, the sine is the y coordinate. So I want to find the when do I have a y coordinate of √2 over 2? Okay, now a lot of these are going to occur twice, right? So you need to think which quadrants, and this is a positive value. So when is sine positive? Quadrant 1 and quadrant 2. So I'm going to have two answers, one in quadrant 1, one in quadrant 2. And so when is that theta? What's the reference angle in quadrant 1? Pi over 4. So I know sine of pi over 4 is √2 over 2. And then the one in quadrant 2 would be 3 pi over 4. It's never going to be a negative angle simply because my theta is always going to be between 0 and 2 pi. Okay, in this example. All right, questions on that one? Yeah.
I just have a question in general. If the number that it gives us is negative, does that mean that it was in like the negative quadrant for whatever like sine, cosine, tangent that is, or does it mean that it's like going up?
Correct. Okay. Yeah, so it doesn't mean that the angle is negative, it just means where the location is. Very good. All right. So let's go down to B. So Lainey just asked about a negative, so let's look at a negative. So for B, sine theta equals -1/2. So then I think, okay, when is the y coordinate negative? Which quadrants? 3 and 4 is when the y coordinate is negative. So then I think, okay, I do the reference angle first in my mind, and then I figure out which angles have a reference angle of that in quadrants 3 and 4. So I go with the absolute value. I say, okay, when is sine equal to 1/2? The reference angle. No. When is the y coordinate 1/2? Sarah? Pi over 6. Y'all hear me? I'm on this one. Okay, so the y coordinate is equal to +1/2 at pi over 6. Does that make sense? If you don't believe me, look at your unit circle, right? Because the sine of pi over 6 is equal to 1/2, correct?
Oh, got it.
Sine of pi over 6 is equal to 1/2, yes?
Yep.
Okay, all right. So now I kind of have like my reference angle. Pi over 6 is not my answer, right? Because I want to look for -1/2. So, but I know it's going to be pi over 6, like, is the reference angle. So then what in the pi over 6 family is quadrant 3 and quadrant 4? 7 pi over 6 and 11 pi over 6. Okay, are we all clear now? I had some confused faces, but we good now? Any questions? Okay, great. All right, so now for problem C. Cosine theta equals +1/2. So now cosine theta is looking at the x coordinate, and I want to be positive. When is the x coordinate positive? 1 and 4, correct. Okay, what is the angle in quadrant 1 when the x coordinate is 1/2? Pi over 3. We just did sine was 1/2 was pi over 6. So then cosine would be 1/2 at pi over 3. And then in quadrant 4, 5 pi over 3. Very good. Questions? All right. Tricky one. Cosine theta equals 0. Pi over 2 and 3 pi over 2. Okay, so let's talk about this. Cosine of theta equals 0. So that's when the x coordinate is 0. Ignore trigonometry and just tell me when is the x coordinate 0? On the y-axis. Correct. So now go back to trigonometry, and what angles are on the y-axis? The 90 degree, which is pi over 2, and 3 pi over 2. Is that good? Okay. All right, now let's go to E and F. Now, remember, I taught you last time, tangent, I kind of think of it as the slope, right? Because it's the y over the x, so I think of it as the slope. So for E, tangent theta equals -1, so to have a y over x equal 1, that means y and x have to be the same. So what reference angle are y and x the same? Pi over 4. Good. Now, in E, bless you, tangent theta is equal to -1. What quadrants is tangent negative? 2 and 4, correct. All right, so now what are the pi over 4 angles in 2 and 4? 3 pi over 4 and 7 pi over 4. Okay, so remember, anytime you have tangent equaling 1 or -1, you're going to be a pi over 4. Now, the other two, the 30 and the 60 angles, the pi over 6 and the pi over 3 angles, remember tangent's going to either be √3 or √3 over 3, right? √3, remember, is steeper. So I think of the little steep x. √3 over 3 is the less steep x, okay? So that's going to be at pi over 6. The steep x will be at pi over 3. Everybody with me? Yes? Okay. So when tangent theta equals pi or √3, that's going to be my steeper angle. And when does that occur? Pi over 3. Good. When else will tangent equal √3? What other quadrant will tangent be positive? Quadrant 3. What is the quadrant 3 angle? 4 pi over 3. All right. Any questions on that? We feel okay because we're going to move on.
Yeah.
Okay. Awesome. Yes.
On like tests and quizzes,
Yeah.
can we be given a unit circle that we can fill out? Or
No.
No. Okay.
Nope. Regular pre-cal, sure.
Okay.
Not this class. Yes.
Wait, so for a sine function, you're looking for the y coordinate, right?
Sine function, you're looking for the y coordinate.
For cosine, are you looking for the x coordinate?
You're looking for the x coordinate.
Tangent is just
Y over x. Sine over cosine. Yes, sir.
But you said we can make like the
You can draw
like reference angle.
all day long. You can draw the whole sine or unit circle if you want. I wouldn't do it, but I'm not going to hand you a piece of paper with a circle on it. Okay, good. Okay. All right, so moving on. So that's inverse. All right, so inverse is the opposite operation, right? When I take sine of something, I spit out an angle. So then I take the inverse of something. Sorry, when I take the sine of an angle, right? I said that wrong. When I take the sine of an angle, I get a value. So if I take the inverse of that value, I get the angle.